So the derivative of the natural log, ln of x, is just 1 over x. So if we have the natural log of something, then the derivative of that is just 1 over that something. So for example, if we had ln of x cubed, then the derivative would be 1 over the inside, which is x cubed. And then we'd have to use the chain rule, since we have a function on the inside instead of just x. So then we would multiply it by the derivative of the inside, 3x squared. And that would be the derivative. So we can use this formula to find the derivative of any logarithm, not just those with the base of e. So if we have the log base a of x, then we can use the change of base formula to change this base a into base e. So we get ln of x over ln of a is the same thing as log base a of x. And then we know how to differentiate ln of x already, so we can just differentiate both sides. So we get dy dx is equal to, now 1 over ln of a is just a constant, because a is a constant, so the ln of a is also a constant. So we can bring it out of the derivative, and then we're just left with the derivative of ln of x, which we just learned is 1 over x. So the derivative of the logarithm with any base a of x is just 1 over x ln of a. So when taking the derivative of logarithms, it's often useful to split the expression apart using log properties. So we have this complicated expression here, and to differentiate it, we can just split it up. So first we're going to use the fact that if we have the log of something over something, we can split it up into the log of the numerator minus the log of the denominator. And then after we do that, we can split up this part further, because the log of something times something is the same thing as the log of the first thing plus the log of the second thing. And then we can further simplify it by moving all these exponents down, because if you have an exponent on your log, but you can move it down to a coefficient. So we move the 2 down here, which becomes 2 ln of x. And then notice I changed this square root of 1 plus x into 1 plus x to the 1/2 power. So now we can move the 1/2 down to the coefficient. And so this is as far as we can simplify it. So now we can go ahead and differentiate. So 2 is a constant, and then the derivative of ln of x is just 1 over x. And then here we have the ln of sine of x. So the outside function is the ln of something, and the derivative of the ln of something is 1 over that something. So we take the inside sine of x and put it on the bottom. So we have 1 over sine of x, and then the inside is another function, so we have to use the chain rule. So then we multiply by the derivative of the inside, which is cosine of x. And then last we have 1/2 as a constant. And then again, first we have 1 over the whole inside. So 1 over 1 plus x. And then by chain rule, we take the derivative of the inside function, which turns out to just be 1. And then we can further simplify this, because cosine over sine of x is just cotangent of x. So this is a derivative of the original expression. Now, logarithmic differentiation is a technique to simplify differentiation using these log properties. Even if the original function doesn't have a logarithm, we can still take the ln of both sides and then split up the expression with log properties. So again, we have a pretty complicated expression. If we were to just use the quotient rule, it would take a long time. So what we can do is take the ln of both sides. So we have the ln of y, and then I went ahead and split it up into the ln of the numerator minus the ln of the denominator. And then we can split this part up because it's a product, so we can split it up into addition of logs. And then now we can go ahead and move all the exponents down to a coefficient. So this is as far as we can simplify it. So now we can go ahead and take the derivative of both sides. So the derivative of ln of y, we have to use implicit differentiation. So first we have 1 over y, because the derivative of ln of something is just 1 over something. And then from implicit differentiation, we have to add the dy dx. And then over here we get 2 times the derivative of ln of x is 1 over x. And then 1/3 times the derivative of this. First we put 7x minus 14, the whole inside expression, under 1. And then from the chain rule, we differentiate this to get times 7. And then minus 4. And then again we have the whole inside 1 plus x squared on the bottom here. And then from the chain rule, we differentiate the inside to get 2x. So we can simplify this a little. Here I factored out a 7 to get 7x minus 2. And then these 7's will cancel out. So you'd have 3 times x minus 2. And then if you distribute the 3, you'd get 1 over 3x minus 6. And then here we have 8x over 1 plus x squared. And so we can then move this y to the right side. And then from original function, y is just equal to this expression here. So we plug this in for y, and that's our final answer.